Okay, last part of the section is p-values. Okay, so we've obviously been dealing with z values. We're going to look at if they're specifically asking about p-values. And you do that, I'll just show you the example in a second. But using a p-value, instead of comparing our z value with 1.96, we compare something to just this 5%. Okay, and that is our p-value, and all it is say our z works out to be 2.16, like in this one here. It's just finding the area of these two, okay, and which is just finding the area of one of them and doubling it. Okay, so, and then if it's small, if the smaller the p-value is, the stronger the evidence against. So if it's less than 0.5, and again we'll look at this in the second example I do, we reject. And if it's greater, then we do not reject. But so for the p statistic, using p-values, if they specifically ask for a p-value, and I'll show you an example that they might ask now, all we do is just draw out this. It's looking for the area of these two. So we find that p is greater than z, and then we just double it. Okay, and that will give us our p-value. And then we'll use that in a test of significance in our second example that we're going to do. Right, so first example, this is the example on page... just 1 second. This is the example on page 343 up the top. So it specifically says calculate the p-value for a sample statistic, and it gives you the z value. So if ever you're asked to do that, it says the sample statistics z is 2.08. The sum of the probabilities, what it wants to do, I'm going to draw this. A z value of 2.08 are these two regions in here. Because we'd be comparing the 2.08 to 1.96, but if we got, say, minus 2.08, we'd be comparing that to minus 1.96. So instead we just find the area of these two. And the way the p-value is equal to 2 times p, that z is greater than z bar. That just means take the positive value. 2 times p, that z is greater than our little z here that we're given, and we use the positive value. So 2. So what we're actually asked to do is find the area of that, or find the probability of that, and then double it. And how do we find the probability of something that's greater than? Remember, our tables only give us less than, so that's where they go, and they go 2 multiplied by 1 minus the probability of z less than, in this case, 2.08. And it's always going to be like this, because they're going to give you this, and you're going to want less than. That's what your tables give you, and then you're going to take away that less than. All right, so we go to our maths tables, and we're looking for 2.08. So our z score is 2.08. That is 0.9812. So 2 times 1 minus 0.9812. That is equal to 2 times 0.0188. So our p-value is equal to, I'll just scroll down there, p-value is equal to double that, 0.0376. Okay, so that's, if you're asked to do the p-value, I'll just talk through that really quickly again. If you're asked to find the p-value, if you're given a z value, you literally go find the z value in the tables, take it away from 1, and then multiply your answer by 2. That's pretty much what all that means, and that gives you your p-value. You've converted your z value into your p-value. Okay, we'll go on to our second example now. Okay, and our second one is involved around steps involved in a test of significance using your p-value. Okay, a test of significance using your p-value. So it's similar to a hypothesis test. Write down the null hypothesis and the alternative hypothesis. You might take down these notes under this little subheading. State the significance level, similar to the last one. Just write down that it's 5% or 0.05. Calculate the test statistics to the z. Then find the corresponding p-value like we've just done there. And then if the p-value is greater than 0.05, we do not reject. So if it's greater than the 5%, we do not reject. And if it's less than or equal to the 5, we do reject in favour of the alternative hypothesis. Okay, and I'll do that with the example. So take down those little notes on doing a test of significance using the p-value, and then we'll do this example, and then that'll be us finished this section. So I'm going to read out the example, but I've already got the numbers written down here. Save us a bit of time. Yeah, I'll do black marker just to... So, first thing, a random sample of 36 observations. So n is 36, is to be taken from a distribution with a standard deviation of 10. Okay, the standard deviation is 10. Remember, if they didn't have the standard deviation of the whole thing, just use whatever the standard deviation is of the sample. In the past, the distribution has had a mean of 83, so all the time they think the mean is 83, but it's believed that the mean has changed. Now, they don't know it, so they're taking it as that, and they're going to do a test of significance. And then it says, out of a sample, they found to have a mean of 86.2. Now you can't go just from that sample and say, oh, the mean is now 86.2, because it is only a sample. So what we do is we do a test of significance. Now I'm going to do the whole one. They skipped the second part, so we'll write down our H here. I'll follow the steps rather than the example. H0 and H1. H0 states that the mean is equal to 83. The alternative to that is that it does not equal 83. And you know, like, you're pretty much going to get full marks for that unless they ask you to write it in context or write it in words, but you'll get full marks for that part, okay? The next thing, the level of significance. They don't write this in the example because they just give it to you in parts. Significance level or 5%. Okay, that's just stating it. So like easy marks at the start here. Then it wants you to find your z-score. So your test statistics, your z, is equal to, again, that formula that we've been using the whole time, x bar minus mu all over standard deviation over square root n. X bar is 86.2 minus 83 all over 10 divided by square root 36. Type it into your calculator carefully, and you should get 1.92. So z is equal to 1.92. Now if you were to draw that in a diagram, I'll just do it up here. 1.92 minus 1.92. What we're looking for is the area of this and seeing going to double it. Now to find that, we can't read that from our tables, so we have to say that our p-value, sorry, I should have said your p-value just so you don't get confused with the probability, is equal to 2 times the probability 1 minus the probability that z is less than 1.92. Okay, we've done that loads of times before. We're looking for 1.92 this time, so our z-score 1.9 and 2, 0.9726. 0.9726. So 1 minus 0.9726, which is equal to 2 times 0.0274. Our p-value is equal to 0.548. 0.0. Okay. Now the last thing we do is we compare that 0.0548 with our 0.05, and we say whether it's less than it or it's equal to it. Okay, so I'll just last point. P-value is greater than 0.5, we do not reject the null hypothesis. If it had have been less than 0.05 or equal to it, we would have said we reject the null hypothesis and accept the alternative. Okay, so it's not that much more difficult. It's always this way. It's always going to be 1 minus the probability that's less than your z-score, because that's how we find it from our tables. Okay, so that's 2 examples today. I'm going to give you a load of questions. Remember, it's the double today, so spend a bit more time in it. And what I'm going to do is I'm going to send you exam questions based on this tomorrow, and we'll suss out a format of doing that and getting help as well with it. Okay? Any questions, just please comment.